hierarchies. And so here I looked at all the topics that we covered last time, as well as the things we're going to cover today and in the next lecture. So today we're going to talk about multiple implements, overloading, overriding. We'll get to dynamic dispatch, which will be sort of the dynamic view of what goes on when you have a type hierarchy. And then we'll have about 10-15 minutes at the end of the class for just QA. So I know this topic is super confusing, so we'll have some time for you to ask questions. So more generally, so this is what we're covering today. On Wednesday, the 2nd, we'll talk about type substitution. And really it's going to be the last piece of material that we'll cover before the midterm. And also by 10-2, you should email any midterm conflicts that you have with the midterm a week from Wednesday. And this Friday, so if Friday I skip, there's going to be a lecture, it's TBD. And then next Monday, so this is Monday, 10-7, we'll have a QA for the midterm. Or essentially, we're not going to cover any new material. We're just going to be here talking about all the stuff that we've learned. I'll maybe have a couple of examples made up so that you can ask me questions. So come with questions on Monday. That's the key thing. And then on Wednesday, next week, in lecture we're going to have programming questions review. So again, not covering new material. We'll mostly be focusing on writing Java code and reading Java code and things like that. And that same Wednesday, the midterm will be 6:30 to 8 p.m. Okay. You guys have any questions about the schedule? All clear? Yeah. Friday? Yeah, it's Good Friday. There's a lecture here at TBD. We're going to figure out what to do. I'll let you know on Wednesday. Any other questions? Great. Okay, so today we're going to be, and by the way, so this concepts page on Piazza basically covers everything you need to know for the midterm. So this is your kind of go-to guide for studying. So it has all the things we've talked about, and I think it's been updated to include all the things we're going to cover today, as well as on Wednesday. So this should be your reference, essentially, for midterm 1. So today in class, we're going to go back to talking about the type poly dispatch starter project. So you can go ahead and check this project out in Eclipse. And we're going to be working through phase 4. So remember, this crazy project has lots of sub-projects. And so last time we talked about the credit card abstraction, and we built that up over time. So phase 4. Phase 4, what we have is this credit card interface. And the interface defines 2 methods. Remember, the interface doesn't implement anything, just defines the kind of things that we want to be associated with the credit card. And so you could authorize an amount, and then you can complete a payment. Very simple. And so what we did last time is we talked about what happens if you have subclasses. Well, if you have classes of different credit cards that implement this interface, like the ASIF card and the subordinate card. And what happens if you want them to share functionality? Right, so there's a bunch of code that I copied from one into the other, and that duplication is really bad. Right, that was the emphasis. And so what we did is we introduced a new class called the abstract credit card. And this class shared, this is where we put all the implementation that we wanted to share between ASIF card and subordinate card. So kind of like last time, I'll draw a little class hierarchy for this version of the credit card. So this is type hierarchy version 1. And so like last time we have an interface at the top. And the interface is the credit card. And then down below, we have 3 classes. Right, so every class gets its own box. So we have the abstract, fill in the fields or the methods for these. I'll just, we're really interested in the type hierarchy. So I'm really interested in the relationship between these boxes as types. And so these two guys underneath here will be the ASIF card and the subordinate card. This is kind of just a review, right? Here are the 4 objects in our system, the 4 classes. And the abstract credit card is going to be an abstract class. Credit card is an interface. This guy is abstract. And these are just standard classes. And what we did is we had the abstract credit card implement this interface. So this relationship, this dotted line, is the implements relationship. Right? And I can only do this if what it points to is an interface. I can only implement an interface. And what I had below is the extends relationship. And that's a solid line. So both ASIF card and subordinate card, they both extend abstract credit card. So this is kind of this is where we left things off last time. So what we did is we added this class and we talked about these different relationships and what's possible and what's impossible within this type hierarchy. Great. So now we'll introduce some new concepts just to motivate these. Let's say that we have this long blurb of text again. So let's say our specification, basically what we need to do in the system changed. Right? So so our spec, this is our old spec, and our new spec includes some new stuff at the bottom here, which is underlined. And the new stuff says that, well, you need to have this audit system. And the audit system needs to allow us to query the credit cards for what they've been used for, what kind of payments they were used for. So I have this constraint. Now I need to query credit cards about previous payments. That's what auditing is. So how would I add this to my type hierarchy? Where would it go? So you have this new constraint, right? You have to be able to query credit cards about their past history. So if I have this system and I've built it and it's working, right? Now I have to extend it. I need to give it this new functionality. What do I do?
You put it in the credit card interface and then decide on your implementation in the abstract credit card class.
Right. So one version of that is to require that this interface contains that extra functionality. So if this method is, get previous authorized payments, for instance, for this audit functionality, I could add a signature here to the credit card interface. So then that requires what? If I add it to this interface, what do I need to do? So if I have a method that's defined in the interface, what do I have to do in the class that implements that interface?
Implement it in the abstract credit card?
I have to implement it. Well, I have to implement it below whatever class that is not abstract. Right? So I could implement it here. I could also decide to implement it here and here. And that choice is left up to me, depending on what exactly I want to add to that method. So give me another way of doing this. So right now we're just like modifying the existing type hierarchy. I'm adding a method. What else could I do? like outside the box. So remember, every time I add new constraints, I added a box essentially to this type hierarchy. Right? And that's a really powerful thing. I add a new type. And when I add a new type, that allows me to rearrange this whole diagram. Right? So one thing I could do is actually say that there's a new type. And I could call this type like an audit type. Or an audit card type. And I could require that both of these cards must be subtypes of that type. Okay, so this is what I'll do. So I'll basically create a new interface. And this will give me a lot of flexibility. And I'll call this guy audit payment. So it's an interface, it's a new box, it's a new type. And so now if I want my ASIF card to be auditable, what I'll do is I'll have it implement this interface. Right, so again, the dash lines implements relationship. So that gives me a lot of flexibility, right? Because now I want my ASIF card to be auditable. I make it, implement this interface. But perhaps my subordinate card, I don't want to be auditable. Right? So really, oftentimes when you add new functionality, something that will give you a lot of flexibility is to create a new type for that functionality within Java. Right? So that's what we'll do now in the code. Let's try this out. So I'm in phase 1. So I'll add a new type. I'll add it to cards. I'll add a new interface. This one is called audit payment. Public. I'll have just one method in this interface. Something that returns all the payments that were made by the credit card. That's really what auditing is all about. So I do something like get recent authorized payments. That's a list, I have to import it. So very simple. I added this interface, and now it's just hanging on as a separate box. There's no relationship between this interface and any other code in my project. So I need to link it in. So for ASIF card, here's my signature of this class. I need to now make it implement this interface. So what do I write? How do I make a class implement a new interface? Implement, right? That's the keyword. Implement my new interface, audit payment. Great. So now I have a class that extends this abstract class. And it's going to implement audit payment. And now I bet you can guess why this is underlined in red. What's the problem? Do you think? What am I missing?
Did you haven't implemented the function in the...
That's right. If this is implementing an interface, then it needs to provide an implementation for all the methods defined in that interface. Right? So what do I need? So that's what this will tell me. This type must implement the inherited abstract method. So I can just add a stub for this method. Just have it return null to begin with. So now I'm using this type, and I have a class that's going to implement this interface. And I just extended my system with this new audit functionality for this specific card. Okay, what if I want the same kind of audit functionality within subordinate card. What do I do? Can you do the same thing?
Should I have abstract credit card implement the interface?
Yeah. So what you're hinting at is a slightly modified solution, but initially what I can do is I can say, oh, well, this guy is going to implement my audit data. And I'll have the same problem. I need to provide an implementation for that method. So I'll provide some implementation down below. And so what I've done now is essentially added a new implements relationship to my type hierarchy. So this is the type hierarchy I wanted, and I added a little bit of something extra. I said, well, what we'll do is actually this. So now both of these classes implement this into the audit. And so what you just suggested is actually an improvement on this, right? So the issue is that while now both of them implement this interface, it's common functionality to all of the subtypes of my abstract credit card. And when I have that, it means that this thing is really abstract. Right? I can like push it up the type hierarchy. So if I were to redraw this, it'll look really similar. My version 2 of the hierarchy is going to be my interface credit card. And then also my interface audit payment. I have these two interfaces. They're really abstract. They have no relationship to each other. And below that, I'll have my abstract credit card. And this abstract credit card is going to implement both interfaces. Right? Because the functionality was abstract enough that I could push it up a level and make sure that all the credit cards in my system share this functionality. Right? That's kind of the new requirement. And then down below, I'll have my actual credit card types. So this will be the subordinate card. This guy will be the ASIC card. So really the two type hierarchies that I just drew, they're very similar. And here's the old version. A little bit more messy looking because of these crossings. Right? I had both of these implemented into this. And then my new type hierarchy looks like this. Slightly cleaner.
You had to say the credit card instead, and you wanted only two of them to implement the audit payment. Would you make an abstract class for audit payment instead?
Good question. Yeah, if I had a third credit card here, and I decided that I wanted it to be a credit card, X card, but I don't want it to implement this interface. What do I do? Right now I'm stuck because basically what this says is that every credit card that subclasses abstract credit card needs to provide this implementation, needs to be auditable. So what I need to do is kind of either go back to this world, right, with this hierarchy where I individually decide which card is going to implement this interface instead of just fighting for all of them. Or I create a new node in the middle for my type card. Right, another abstract class here that this guy will subclass, and then this will implement my credit card interface. So there's a couple of different solutions, and this is pure object-oriented design. So you have to be thinking about the evolution of your system and what you want to get out of it. So the answer will differ. You know, there's not one answer. Just like the difference between these two type hierarchies that I gave you, you know, which one's right? Kind of depends. Kind of depends on what you want from your system. So in our code, we haven't finished our code, right? Because we are still in this world of the old type hierarchy, where both of the classes down below implement this interface. So what I'll do is remove this implements, and I'll add it to the abstract credit card. So my abstract credit card is going to implement two things, which is kind of cool. Right, I still need the implement statement. I just need one though, and then I just list all of the interfaces that it implements. And if I save this, and in my ACID card, I can do the same. Remove this. Then what I can do is I can refactor this common functionality, and I can push it up to the abstract credit card. Okay, so my abstract credit card is going to now have both interfaces. And when you have two interfaces, the best way of thinking about it is that you can look at the object from two angles. You can treat it as a credit card, because that's what this says. It implements credit card. Or you could treat it as an audit payment type. And you can have both in this case, because it implements both of them. So, because it implements both of them, and because it is subclassed by subordinate card and also ACID card, that means that the same is true for the ACID card and the subordinate card. You can think of the ACID card as just a credit card, or you could think of it as an audit payment. So that's really the subtype and the supertype relationship. Right, just to review, back in this type hierarchy, the things above are the supertypes, the things below are the subtypes. Right, so the credit card interface, credit card type, is the supertype for abstract credit card, but it's also the supertype for the ACID card and the subordinate card. And the subclass superclass relationship is purely in this extends keyword, right? So this is the superclass, this is the subclass. Great. So what if I have another constraint? What if I wanted to make sure that I can pay my credit card in different currencies, like different amounts? Let's say I'm here in Canada, I'm paying Canadian dollars, but then I go to Europe, I go to Germany, and I want to pay in euros. Right, my credit card right now, my credit card interface, says that when you authorize an amount, it's double amount. It doesn't tell us what kind of currency it is. Right, so it's not expressive enough to capture the reality that you might be using your credit card in different countries. So how do you think you would capture that? This is yet another extension. What do you guys think? So when I authorize this amount, I'm telling credit card, authorize for this amount of money, for this amount of Canadian dollars, whatever. But it seems like I need a different kind of authorized amount. and I want to call the authorized amount depending on which country I'm in, depending on what kind of amount I'm talking about. Right? So, I could, for example, going back to this type hierarchy, I could say, well, if you have a credit card, maybe what you want is a Canadian credit card. Maybe I should create a new type. Create a Germany credit card. I'll make this an interface. I'll have the same exact methods. And then if I want some card to be a German card, then I'll need to say, well, okay, well in that case, I'll have a German abstract card. It will implement this command. And then some X card will extend it. But this is one way of solving it, right? What's wrong with this? That just define a new type, right? This is great. I have a German card, now I have a Canadian card, and now I just need, 200 more cards for every country in the world. Right? So I have this proliferation of types because I made them too fine, too refined, right? So this is not a good abstraction to pin these to specific countries. What I want, all I wanted, is a different kind of authorized amount. Okay, so here's another solution. Locally Boolean authorized euro amount, double amount. That seems a little simpler, right? I define a new method. The method is specific to the country that I'm in. I don't have a new type. Credit card is still just a credit card. What's the problem with this? Why is this a bad idea?
You will need a lot of functions to work.
I'll need a lot of functions, right? So I'll need a lot of functions, so I'll have to be really creative with my names, or function names, right? I'll need over 200 of them again. It's a very similar problem. I think there's another problem that's really bad, which is that if you're at a store and you're shopping with a credit card, you really just want to call authorized amount. I don't want to know what is the specific method name that I have to call. So that in Germany, I have to know to call authorized euro amount. And in US, I have to call authorized US amount. That would be very specific, right? I just want to always call this function. So the concept that Java has to allow for this, so there are many ways of doing this, right? And I showed you a couple of them. But really, it's a pain. So there's another concept, and the concept is called overloading. So when you overload an authorized amount method. What that means is I'll provide a method that has the same name. The same name as another method will vary in the kinds of arguments that it takes. And I can say what I want actually is what's important is not that this is a double. A double is just an integer with a decimal point, so like 10.5 is a double. It's not important is the quantity, what's important is the type of this amount. So, there's a defined currency amount. So perhaps I have a default behavior where this is my home country, Canada. I'll just call authorized amount with just the amount. I don't need to specify the currency. But when I'm traveling in a different country, I'll call this authorized amount with a specific currency which will depend on where I am. Right, so in the type hierarchy, this means is that I just added a new currency class. And I'm referring to it from my interface. So what I could do now is I could say, credit card C equals new ASIF card. Remember, I can do this because this is a super type, this is a subtype. And then I can do C dot authorized amount. Create a new currency object. But I could also do C dot authorize amount, and then specify a specific amount. So this is overloading. And when I overload, I create methods that have identical names. But what differs is their arguments. So authorize amount here takes a different argument. And so when you're running the program at runtime, Java will decide, oh, is the argument currency amount, currency object, or is it a double object? And then depending on which of these you give it, you'll call either this authorized amount or a different authorized amount. So it's going to be resolved dynamically at runtime. Questions?
What is a double amount?
Yeah, double amount. So double is another primitive type. It's kind of like int. You know, so int is another primitive type. So an int is an integer. Could be negative, could be positive. It's a whole number. And double is a fraction. It has a decimal point. So you could say it has, you know, it could be 5.5, 2.3, and so forth. So higher precision. Other questions about overloading? Okay, so let's talk about another topic. Let's talk about overriding. So two very similar words, overloading, overriding. Don't confuse them. Overloading, just using it to refer to the fact that I can have methods that have the same name. When I'm overriding, I'm talking about something completely different. So, look at the type hierarchy again. Let's forget about these additions to it. So this is my type hierarchy. And remember that my credit card allows me to authorize an amount. Right, let's say it's just this double amount of currency. And this authorized amount, I have some implementation for it here in my abstract credit card. And this implementation is shared. So an ASIF card and a subordinate card, when I call authorized amount, it calls the authorized amount implementation in this class. But what if I want a different kind of authorized amount? I want my authorized amount method to do something different depending on whether you're an ASIF card or a subordinate card. So in that case, what you need to do is add a method called authorized amount to one of those cards. So let's say I'm an ASIF card. I just have the constructor here because everything got pushed out to the abstract credit card. So if I wanted to add an implementation of authorize amount that's specific to the ACID card, I would do it here. And when you do this, usually add the annotation override. And that override, this little thing on top of a method, tells Java compiler that this is providing an alternative implementation for a method that has the same name somewhere up the type card. So my abstract credit card has an implementation of this method, and I'm defining one, a different one possibly here. So this is where the super keyword came in. Remember last time? Super allows me to refer to my super class. So here, if I want to just essentially do the same thing that abstract credit card does, I'll just say super dot authorize amount, output amount. And I have to return. Okay, so by adding this, this is essentially a no-op. This doesn't change. This doesn't change anything in my project. It just basically said, well, I want to do something else. Now just go ahead and do whatever my superclass does. Right, so this is essentially a stub. Doesn't do much. But I could have some other things. So I could have it use this authorize amount in some way. For example, I could define a variable boolean authorized equals this. And then I could say if authorized, maybe I'll print a little message. Congratulations, you're authorized.
Doesn't the super already refer to authorized amount already? So confused by why you would need a dot authorized amount after the super.
So super refers to my super class. So it refers to an instance of my super class. Right? So just like this refers to an instance of this object. So if I want to then call a method on this instance, I do this dot something. Right? So I can call authorize amount here. And this is going to invoke the same method, right, from inside. So this is an infinite loop. So if I want to invoke my authorize amount defined in the superclass, then I'll write super dot authorize amount. And what this will do is we'll call the authorize amount here, this guy, and my abstract credit card. So that's what the super allows me to do. It allows me to refer to my superclass. And through that, I can do things like access fields. If they're visible to me, I can call methods. Right? Basically the things I could do with an object. So what I did here is I called authorize amount. So I did what my superclass does, and then I provided extra functionality. This is very common in Java. Right? I'm doing whatever my superclass does, and then I have some extra functionality that says, well, if you're authorized, I'll print out this nice thing. The ACID card, I could say, presents a card from the friendly ACID card. And it does a little something extra for the user, like a nice message. So in the new assignment that you'll be working on, assignment 4, you'll be essentially needing to do this within that scope of that assignment. You'll add a new class, and you'll need to override an existing method in the superclass. So this is overriding. So when I'm not overriding a method, so let's say I'm in subordinate card, I have no authorize amount override. When I have an instance of this object, and I call authorize amount on it, it goes directly to the superclass. It goes directly to the abstract credit card. And that process is called dynamic dispatching. So, kind of a fancy word for figuring out what version, what implementation of a method you're going to invoke at runtime. So I'll actually show you this with the tests. So let's say I have my test for the credit card. I don't know, I could really pause any of them. So remember that these tests gets reused, right? It gets reused for a card as well as the subordinate card. So my A credit card within this class refers to a credit card. So the parent type is the credit card. But the actual type will vary depending on what object I'll create and what I'll assign it to. So at runtime, my actual type will be either ACID card or subordinate card. So if I run my test, maybe I can just run my ACID card test. So all my tests pass. If I want to debug the test, I press on the little bug. And my code will pause right here. So that's my breakpoint. And so now, a credit card, the parent type is exactly the type of the code, the credit card. But the actual type is going to be ACID card. If I hover over it, it tells me that it's actually an ACID card. So when I call this authorize amount, what I could do is actually step into that call. So at the top I have these things. Remember we used step over before, but you can use step into. And if I step into, I'm going to go into the method that I'm invoking, and then I'll pause. So if I step into, I'm going to end up in the ACID card class, in the authorize amount of this defined in this class. Because my actual type is an ACID card. And I can step into repeatedly, right? So if I step into the super.authorize amount, then where am I going to end up? Where's it going to take me? What's the superclass of ACID card? Abstract credit card, right? So when I call super.authorize amount, it's going to end up in the authorized amount of my abstract credit card. I hope. So step into it. Here I am. Now I'm in the abstract credit card class. So what I'm doing is I'm tracing the execution at runtime to figure out where I end up. And that allows me to explore this type hierarchy that I drew for you dynamically. So I get to see what actually goes on when I create a credit card object and I call methods on it. So I can step over these statements. And then when I return, I come back and I'm again in the ACID card. I can step over these. And look, it's authorized. So what that means is you'll get a little printout on your console. And then when I step over this, I come back, and here I am again in the test. So if I run this thing, it's going to pause again, maybe. Here it pauses at a different method. In test authorize amount inbounds. And so my credit card is still ACID card, so I know it's going to call the ACID card version of it. And if I execute the other test for the subordinate card, the parent type is still going to be the same, but my actual type will be different. So if I run these unit tests, it's going to pause in the same spot. I'll actually debug it first. So it pauses here. So now my egg credit card, the parent type is the same, but now it's a subordinate card. Right? We're in a different spot in the type hierarchy. So if I try to step into this authorize amount, where am I going to go? Where is it going to take me? the last time when I had the ASIF card, I ended up in the ASIF card class. But the reason for that was because I overridden the authorized amount method. This time, my subordinate card, if I look at the code, subordinate card, look, there's nothing here. It's just a constructor. So when I step into this test, step into this call, I'll end up in the abstract code. Right? I'm going to jump and go to my super table. So to review, at runtime, we had one of two actual types. We were either here in ASIF card, or we were here in subordinate card. And so when we invoked the method on ASIF card, we chose the implementation that was closest to our actual type. So ASIF card has an implementation of authorized amount. So this is the function that we call it. This guy doesn't have an implementation of authorized amount. So what it did is it went up to the superclass and it called the authorized amount implemented there. Right? So that's dynamic dispatch. So at runtime, Java decides which implementation to call depending on the actual type. Great. So next time we're going to cover substitutability. Will be the last topic.